Good day, students, and good day, miss. In this video, I'm going to explain a polysaccharide known as amylose. It is a component of starch. It is also known as a complex carbohydrate. So what are starches? Starches are storage forms of glucose found in plants. 10 to 30% of plant starch is in the form of a linear polymer. This linear polymer is simply a chain in which all of the carbon bonds exist in a straight line. Amylose is found in these foods: cornstarch, sweet potatoes, legumes, and brown rice. So what are the functions of amylose? The key functions are energy storage and food reserves. So a huge variety of polysaccharides can be formed by changing the type of monosaccharide represented here and incorporate it into a glucose polymer. This glucose polymer forms the 1,4 glycosidic bond. So what is the structure of amylose? Well, it is a combination of this alpha-D-glucopyranose. Represented here is carbon 1, 2, 3, 4, 5, and 6, where at carbon 6, the CH2OH group of the chiral carbon determines the D configuration. And between the H and OH group, you can find the anomeric carbon. The OH group on the anomeric carbon is below the plane. So if we combine another N mole of this D-glucopyranose, we will get the alpha 1 to 4 linkages. These alpha glucose that form these linkages forms long chains with thousands of subunits. These linkages are bonded together by a condensation reaction by getting rid of the water molecules forming the 1 to 4 glycosidic bond. So each time a D-glucopyranose is added, it is a condensation reaction adding another unit of the D-glucopyranose every single time. This is why amylose consists of a polypeptide chain of glucose bonded together. Represented here, you can see the glycosidic bond. Amylose actually form a spiral much like coiled spring, hence the name helical or helix chain. It is held together between the CH2OH groups. This is what pulls and twists the chains. This allows it to store large molecules in small spaces. Amylose functional group units are connected by an alpha acetal linkage. Connected carbon 1 of this glucose to carbon 4 of another glucose. Amylose is hydrophobic, meaning it is insoluble in water. The question is why? Short answer, it is relatively nonpolar. It's in its crystallized form, hydrogen bonds form to generate a helical structure, occupying places where polarity might otherwise be able to occur in the molecule and allow it to solubilize in a polar fluid like water. Therefore, it is known as hydrophobic. So in conclusion, amylose is a polysaccharide, consists of a linear structure of alpha-D-glucomonomers linked together through an alpha 1 to 4 glycosidic linkage. It has a helical structure that possesses the H atom but is hydrophobic in nature. Thank you.